Hi everybody and welcome. Today's video we are going to be taking another look at arithmetic and geometric sequences, but our goal for this video is to kind of see them without knowing what's going on. And what I mean by that is it's not going to be like, here's an arithmetic sequence, find the sum. Today we're going to focus on just seeing a sequence and then identifying it on our own and then applying that correct formula on our own. So up until this point it's been reasonably clear which type we were working with. In the questions you were basically told which one it was. So now we're going to take that next step and look towards basically identifying these things independently. The first thing though, in order to start our work today, we need some notes. We need to remember from 9.1 and 9.2 what our formulas are. So we're going to start off with some formula review. For arithmetic sequences and series, to find a given term, so to find a given term, we define it as our first term plus the number of that term minus 1 times our common difference. So a subscript 1 is our first term, d is our common difference, and n is the number of the term. So that's our first formula. Our next formula is to find the sum. So the sum of a given number of terms is the number of terms divided by 2. And then 2 times that first term plus the number of terms minus 1 times the common difference. So S subscript n is the sum of a number of terms. Next, for geometric series, we have to find a given term, so it still means the same thing. A subscript n is our first term times our common ratio to the n minus 1 power. R, again, define that as our common ratio. Next, we have two summation formulas for geometric. So first term minus first term times common ratio to the n over 1 minus the common ratio. In this one, we use if n is known. Our next one, summation of a given number, is our first term minus the last term times our common ratio over 1 minus our common ratio, and we use this if our last term is given or known. And that's kind of a recap of 9.1 through 9.3. So if you have these formulas, you know what these things mean. We did study guide slides the other day. This is going to kind of help you get started with what to do. So let's go over, we'll do a few examples here today. So first thing first, let's start off with something like 39, 49, 59, and 69, and we want to find the sum. Well, let's label everything we know. So we know our first term, we know our last term, or our fourth term. We know because of this that n equals 4, because we have 4 total terms. To get from our first to our second, we add 10. Same thing for second and third and fourth. So because we're using addition, let's say our common difference is 10, and we can use that in our formula. So because it is addition, we can say that this is arithmetic. So we're going to use our arithmetic sum formula. So the sum of our 4 terms here, we can plug in. So we know that n is 4. We know our first term is 39. Again, n is 4, and we know our difference is 10. So we can work through and kind of take this one step at a time, enter it into the calculator, and we should get a final answer when we do that of 216. So again, kind of take it one step at a time, subtract, multiply, and then your last step would be to multiply by the number on the outside. And again, that last step, jumping all the way down to 216, we can do that because it's calculator math at that point. We can just enter all of that in and do it in one step. Let's go over a second question now. A second series of numbers. And let's do exactly what we did before. We know our first term. We know our last term. We know that we have 4 terms. To get from 2 to 12, we add 10. But it looks like we don't add 10 to 12 to get to 72. So what do we do here? Well, it looks like we're multiplying by 6. So we're going to call R our common ratio 6 because we multiply. This is geometric. If we look at our formulas, we have both our last term and our n given, so it actually doesn't matter which one we use. So if we're looking for our sum of our 4th term, let's just choose the first one. So first term minus first term times our common ratio to the n power over 1 minus our common ratio. And then we can work through here and solve. So we can enter what's in on top there in the calculator. And we should get an answer of 518. So again, punch all of this in up top, parentheses, division sign, everything on the bottom, divide, and we'll get 518. So it takes a few moments there to punch it in, but again, be careful. You can still do it one step at a time. I'd encourage that if you're not feeling comfortable entering this in. But 518 is our answer for this geometric series. The last thing that we're going to go over is an example where we don't have everything that we need right away. So we want to find the sum of the following series. They give us the first term is 4. They tell us that our last term is 8,748, and they tell us that our common ratio is 3. And based off this information, we should be able to solve. So first things first, we have a R value, or a common ratio, which means that it must be geometric. If it had a D, it would be arithmetic, but here we just have an R. Next, we need to take a look at some things that we need to solve. It looks like we have our a to the n given, so based off of this, we can use our second formula. So sum of a given number is our first term minus our last term times r, all over 1 minus r. And the nice thing is we don't actually have to do any extra work here if we use the right formula. So we'll have 4 minus 8,748 times our r value of 3, all over 1 minus 3. And if we do this, punch everything in on top, so multiply here, then subtract, and divide it, we'll get a summation answer of 13,120. So that's our goal as we're working through here, is really to rely pretty closely on the formulas. They're going to really be some key guiding steps for us, and they're going to tell us, A, what type of series do we have, but B, beyond what type